And okay.
Bing, bang, boom. Okay, so hi everybody tuning in asynchronously. As a friendly reminder, my name is Hannah Helbin, and I am the comms person for this lovely project, Eclipse Megamovie. We've spent a few minutes catching up, and I presented at ASP over the weekend, so we thought it would be a fun idea to go over the slides, and I could just really quick do a bing, bang, boom presentation. Caffeine is running out though, so forgive me if I slip into silly. So yeah, here's the slides. These pictures everybody's seen. We use these slides quite often on our Eclipse Megamovie presentations. But first I started off with a conversation about like what is Eclipse Megamovie, what was EM 2017, how is it different from EM 2024, like were the volunteers different? Really, it was kind of the same deal, but our standards for the pictures were really different. Is kind of the consensus that I reached. And this is one of my favorite pictures. You'll see another one of my favorite pictures a little later in the presentation. But really just EM 2017 didn't ask anyone to take flats and darks. EM 2024 did. And that was made very possible by the photography guide that Jeffrey Reedy and Laura Peticolas really just slaved over. I mean, a lot of blood, sweat, and tears went into that photography guide. And it sounds like it served its purpose and it was a hit. So that was really refreshing to hear too. We can just really quick watch the OG Megamovie. And of course, as we track forward, so too does the progress of the moon shadow across the US track forward a bit. Kind of just as a basic, visual explanation to what the Megamovie is and was and will continue to be.
I'm not seeing anything. Is anybody else? Is
Oh,
everybody
really?
else seeing?
Please sharing the screen, Gary.
So Gary, up at the top, oops, thing. Up at the
Well,
top,
you can't
if your no, yeah, if your Zoom is updated, there should be tabs at the top of your Zoom.
Yeah.
And so now you have the option of either just staring at my face or looking at my screen. So it should say meeting and then Hannah Hellman's screen, I think.
Yeah, do you see those two tabs at the very top next to the little circles for closing your window and minimizing the window?
Oh, hi, kitty.
And
I love it when cats disrupt meetings. Not just the cat's not a disruption. I'm
Is it
disrupting the
switched to
meeting.
shared content?
Yes,
Yeah.
I think so.
There we go. Okay.
Hey, there we go. So there's the Megamovie. Still going.
So it's
going
like
strong.
almost the Wyoming border from. It's past. It's
I
gone
skipped
all the
it.
way across Wyoming. Damn, that was fast.
Light speed. So there's the good old fashioned Megamovie. Of course, here is the mount. Just some numbers, and I'll really quick read these off for you guys too. We had 145 volunteers total send us pictures. 94 of you guys said that you got good photographs of the corona based on the follow-up survey that you filled out. 45 of those 94 said they got flats and darks or sent us flats and darks. This led to over 1 terabyte of data, of just photographic data collected from everybody. 172 cameras total, and 94% of those cameras were DSLR, telescope, or higher quality camera, which is really cool, considering especially that the study that we based, or the research paper that we based kind of the direction this project would go on, had 7 such photographers. We're going to get some really cool things out of this data. Here's a little bit about the machine learning efforts, and this is kind of just a quick introduction. Hopefully we'll hear more about it in a little bit. Really, it comes down to labeling the 2017 Eclipse photograph set, and labeling means any number of these categories here. So we've got 0 to 25% partial, we've got 26 to 55% partial. Note, not a solar eclipse is a category, and there are several pictures we got that are not a solar eclipse. And then there's total solar eclipse. So that does make up a very vast majority of the data received, but it is still important to be able to label all of these other kinds of photographs too, because the idea is we will use this training as a way to train on the 2024 data set, so that the labeling of it the rotation of it, the alignment of it is all going to be so much smoother than it was for the 2017 data set, not to mention all the calibration shots we have. So it's going to be very exciting. 2 algorithms were written. Some of this is still pretty over my head, but my understanding is 2 algorithms were written, 2 different ways of 2 different machines that will basically label the pictures for us, right? There's a manual classifier and CNN code. I don't remember what CNN stands for. Maybe Troy can jump in for 2 seconds and tell me.
Convolutional neural network.
Convolutional neural network. Thank you, Troy.
There will not be a spelling quiz, correct?
No, there will not be. Here, if you're interested in that kind of thing, if machine learning is your, if you understand machine learning and you want to look at the code, here's where you find the code. These doggos do qualify as not a solar eclipse in the category. I just really love that picture. And so now next steps. Basically, whenever somebody would let us know, hey, the metadata in the picture that we sent you is not correct. The lat long is not going to be accurate to where the picture was snapped, or the time that it was taken was not set to the correct time zone where it was actually taken. It was instead my home time zone. We got some of that data after the fact. So we do need to go in and manually update that metadata, which will take some time and some effort, but it is by no means impossible. And then also, one of the other things that we want to do is further develop the code used for the machine learning based off of what the students did. But for that effort, we are going to be launching the Kaggle competition, which many have heard about. Troy is leading the charge on that, and it's going to be really, really cool. I can't talk about much of it because I don't understand it that well, but I can tell you that it's turning out to be really cool. This will also include working on the Python code from analyzing the 2017 data set, taking that and updating it, developing it more to process the 2024 data set. And we're working on making it available to everybody. It's a lot of data. We're working on it. This is lessons learned, more aimed at anyone who is leading a project like this. And so, if you wind up leading a project like this and you, for example, want the like a code of conduct to base for your community, to make sure that your community treats each other with respect, for example, NASA has a handbook for that. NASA Citizen Science specifically, that QR code leads to that handbook. And really just the thing that stood out to us this year with this project was that so many of you came to the table with things that were invaluable. I mean, like your expertise in everything ranging from eclipses to photography, to eclipse photography, to photographing the ISS, and just, seeing you guys connect over those things. It blew me away. And so many of you really contributed to the development of the project in a lot of senses. You helped us with the photography guide. You helped us with our standards. If it were just us telling you what to do and not taking feedback from you, we would have sunk, honestly. I think it's safe to say that. So this might look familiar to He. I pulled this off of the Discord He. So I showed just a little bit of your time lapse. And I made sure to point out, people pulling up and asking you like, well, what's going on? What are you doing? Why are you here? And then we get into totality. Beautiful. So cool. And then we exit totality. So it duplicated a couple slides. I don't know why. This might look familiar to Raphael. Also pulled from the Discord, another phenomenal totality shots. And here is one from Nastronomy or Nasmus this year. I'm not sure if he's here today, but we did a highlight, which is what this is on the right here. We did a highlight with NASA Citizen Science. So this is coming your way. I'm gonna ask you some questions. And if anyone else is interested in doing a volunteer highlight, please reach out to me at my email. Just send me an email and say, hey, I want to do a volunteer highlight. We can do as many as we want. And this QR code will take you to that highlight. And then just a few more. This is from J Boy Mel. I don't remember their name, so I couldn't properly credit them, but that is their Discord username. If you're here and it was yours, please let me know and I will update to make sure you get credit. Here's from Jay Davis. I really like this shot. That last little tiny sliver of a thumbnail of the sun's light. All right, and then I told them to come to the meeting tonight. And that is the QR code for our link tree. Ba-ba-da-bum. I hope I properly represented you guys. Okay, I think I can stop sharing. So let's see.
Any questions
what's
or
next?
comments for Hannah? I saw there was a question about the data and hoping that it's backed up in multiple places. It is officially backed up now in 2 places. So we're getting there. We will probably, we have a couple, as you know, Raphael is at NASA's Goddard Space Flight Center, and then we have another colleague there who talked to us at our last team meeting about hosting a first version of the data set at a server there. So we'll probably get the data out in a couple different manners. So one is just, as Dara was saying, I mean, as Hannah was saying, we need to clean it up and just make sure all the metadata is correct. And then the other goal that we want to meet is to make all of the images FITS files. And FITS files, for those of you who are not astrophotographers or astronomers, is a way to format the information about that photograph in metadata in a way that's used by astronomers. And there's a standardized format for that. So we'll use specific names, and that will also take us some more time. So, but we want to get the data out before that. Yeah. That's the only thing I wanted to add to what Hannah said. Any questions, comments?
Right.
Okay.
We will put the code in the Python channel. Awesome. Super cool.
All right. So I think we're not quite sure what happened to our guest speaker today. He was all ready to come and had the link and is not here. And so I think our backup plan is that Troy and I will go over the poster that they created, that our students here created, and kind of take you through it, as well as, I mean, really, Troy will do it and I will help translate if needed. Does that sound okay, Troy? Do you have the poster up and ready? Do you want me to share it? What do you?
I don't have it up and ready. If you have it ready.
I think I have it easily accessible. Okay, let's see.
Maybe while Laura looks, he can tell us what the better poster movement is.
A way of reimagining posters. A lot of people treat posters as you take your 24 PowerPoint slides for a half an hour talk, you then paste them onto a 2x4 or 4x8 foot. And I apologize for the non-SI units for those of you who are. But a poster is not a slideshow. A poster is a conversation, and so the better poster hashtag is something that was developed by either a grad student or a postdoc. I don't remember. Where a large chunk of the real estate is devoted to the key thought in the middle of a poster, and then you have the supporting data on the side, and it's a way of engaging the participant in more conversations.
Oh, very cool.
I've attempted to try to get my colleagues at work to adopt go adopt that. So I'm that word. I'd like to convince people that's a better idea.
Cool.
So Laura, go
Awesome.
ahead,
Thank
please.
you,
Okay. All right. Share. Okay, so I'm gonna zoom in. My machine is complaining for some reason. I don't know why. Where do I zoom?
I think Command Plus will do it for us.
Yeah,
in the bottom right corner.
Oh yeah, there we go. Command Plus is not working for me. Okay. I'm going to close this part and I'm going to, okay, so here's the title. So let me just give you some context. So these, Ethan, Matthew, Obina, and Nick were Sonoma State University students. They worked with Professor Gurman Gill after Troy and I presented this option to them as something they could work on. It was funded, their work, that they actually got some funding to do this through the Correct Foundation. And so both our foundation, our funding from NASA as well as the Correct Foundation supported their work. And so the introduction, what we were asking them to do was to look at, ultimately to help us kind of sort through all of the images that you all uploaded in this year, to help us organize it in terms of different classes of types of data. So these are our data set types, and as you know, when you uploaded your data, the lights that you uploaded, we asked you, they may have been partials, they may have been diamond rings, they may have been total eclipses. And so we will want to pull out just the total eclipses for a specific, for certain types of analyses and other data for other analyses. And so, and this was a doable project in terms of creating an automated system that could accurately identify whether there's a solar eclipse in an image and the phase of the eclipse. Okay, so that's all I know because that's the part where I had to pass it over to Troy. And Troy taught me a bunch of stuff about, Troy and these students, in fact, taught me a lot about machine learning that I didn't really know or had lots of misconceptions about. So Troy, take it away from here and tell me where you want me to go on the poster.
Sure. So I suppose we can talk about the data set distribution, which is a little bit lower. I should, I guess, preface this with I obviously was not as involved in this project as Obinia was, who was going to present this, so bear with us. So the data set in general presents an issue in being that there are a lot more images of total solar eclipses than there are of everything else, probably combined. And to train a machine learning model properly, it's ideal that you have an even amount throughout so that it learns all of the different phases or different things that it's trying to learn evenly well. So one of the issues is that this is a very total solar eclipse leaning project, naturally. So I believe what they did primarily was create synthetic data in basically copying images of the 25%, the 25%, and doing slight rotations on them, making some of them a little bit bigger, a little bit smaller, just so they're not exactly the same images, but they're very slightly different. Is a I forget the term. There's a term for it in machine learning, uh, like artificial mutation or something like that. That technique is for. So beyond that, they worked on two models, if I'm remembering correctly. Oh, this as well. Let me talk about this first. This is a different issue with the data set as a whole, is that we presented them with a lot of images, but not a lot of labeled images. And something that is important in machine learning is having a set of data that you already know the answers to, so that when you present it new images, it then can accurately accurately sort those images based on what it knows. And so part of the problem is that we didn't have a lot of labeled images. So with this classification script, they were able to efficiently manually label them. If I am remembering correctly, based on what some of the students had told me, it basically showed them an image and then they could hit a button and it would sort it into a bucket, and then show you the next image, sort it into a bucket, et cetera, et cetera.
Let me jump in real quick, Troy. Just to say, for those of you who have used Zooniverse before, which is a citizen science platform, a lot of the classifications have been done in that manner, showing an image of something, some type of galaxy or even solar jets, and then people go through that. So this student basically created a little module very similar to things that are being done on this Zooniverse platform. So I was really impressed with that student's work to do that. And then I also, above this classification script, you can see the classifications that we gave them: 0 to 25% partial eclipse, 26 to 55% partial eclipse, 56 to 95% partial eclipse, darks, diamond ring, Bailey beads, flats, not a solar eclipse, and total solar eclipse. So we went through and I found all the different types of data but it wasn't a lot. It was something like 400 labeled images. And then I think they got up to about 1,000. Is that what you remember? Labeled?
If I recall, it's about 1,000. So
Yeah.
they labeled themselves probably about 600 images, which, as you'll see later, ended up working out in their favor, as they got accuracies around 80-90%.
Yeah, so do you want to talk about this one first before the CNN, or
We can talk about the bag of words first. I will say I don't know bag of words method that well. A lot of my projects that I've personally done with machine learning are with convolutional neural networks. So that's more where my expertise lies. But I can say that this is more of a sort of a feature defining and categorizing algorithm. And one of the important things to point out is that this was less effective less effective in general, and less effective, I believe, specifically at finding total solar eclipses,
Mhm.
while the convolutional neural network was specifically better at doing total solar eclipses. And I think this one was better at finding the Bailey bead, if I'm remembering correctly.
Yeah, and the diamond ring. And so you can see here this confusion matrix, which I didn't know, I hadn't been introduced to this idea until this project, frankly. And so let me just so a confusion matrix just tells you how well did this this algorithm, how well did it do in sorting all of the data. And so you can see like 21, is this 21%?
No, that is 21 images. And you
Okay,
can see on the left there, those are the actual labels, and on the bottom label is what are predicted. So in a perfect world, in a perfect algorithm, it should only be numbers in the diagonal.
yeah, and you can see the total number. Yeah, so 51, it looks like there was probably 60 images or something here in each or something. Yeah, so like this one was 21, that looks pretty good. Because there's zeros in all of this row and in this, whoops, column. Is that what you're saying, right? That this 21 captured most of them?
It looks like all of them that were actually 25% were accurately predicted to be 25%.
Mm-hmm.
And the ones that were like 26 to 55, it looks like there were 3 of them that were incorrectly predicted to be 56%, 5 that were incorrectly predicted to be diamond rings, 1 that was incorrectly not an eclipse, and 0 that were incorrectly a total solar eclipse, but 14 that were correctly 26 to 55.
Okay, this is helpful having you talk through this, I think, for everyone. Okay, so then you can see this one there. So even though there are 51 with the diamond ring, there were still some that were predicted to be other classifications that were incorrect. Right? So this time, so I was reading this a little bit wrong earlier. Okay.
Yeah, so there are
But just because
51
it's
that
darker doesn't mean it was more accurate. And in fact, this one this partial 0 to 25% partial looks to be the most accurate
I
based on
believe it's based on quantity, the color. Because even though percentage wise, the 25% one is better, because there's 51 images, that's why it's so dark.
Yeah. Okay. Raphael raised his hand. Go ahead.
Yeah, apologies if you already answered that. Trying to also do some budget things at the same time, sorry. How did you deal with the fact that across the different images you received from different volunteers, I'm guessing because they used not identical lenses and not identical focal lengths, not identical sensors, I guess you ended up with different sizes for the images where the size of the sun changes from one image to the next. I mean, was that the case? Did you have a broad range of sizes for
Yeah,
the
there were
sun?
completely different sizes in the images that we were given.
And yeah, how did you deal with those differences when you send that to the neural net? Is there an extra information or a pre-processing where you attempt to make the sun of equivalent sizes across the different images or not?
No, so when you train a machine learning model like this, it actually in more of a convolutional neural network, it it looks through every pixel of the image, and through this large network of checking each pixel and making associations with other pixels, it finds details that it can identify. So like the shape of the sun, the like circular shape, like the corona, it finds the shapes and the colors and stuff of like that, and is able to learn what the actual sun looks like based on associated pixel values. So it doesn't matter like what the size is if it can learn how to identify the shape.
Okay, I develop convolutional neural nets, my job, routinely, and actually, what you say depends on the architecture you choose. So,
Yes.
the convolutional neural nets are not all independent of the size of the image you put in. So, there is always multi-scale capacities, but when you're in a given layer, all your um, the features that are being built, they are capturing a certain scale that still depends on the size of the convoluted step where you're at. So after the first layer, if you have a convolution that is 2x2 or 4x4, you're going to have a reduction of the size of the image of that much. And this is what that layer is going to see.
Oh, I think I understand what you're saying. So the pre-processing to change the size of the images as a total, right? Or am
No,
I misunderstanding?
I mean, I just meant that if you do not pre-process the images so that they have equivalent sizes, um, the depending on your architecture, you are introducing then some inconsistencies in the learning, because for a given layer, all your different features are going to be fed with a sun that doesn't have the same size from one node to the next.
Right.
And
Yeah.
for a given layer, then when you change the layer, there is a new reduction in sizes, and again, you changes the range of different sizes of the sun. So it's just that something you should pay attention to. And if you're looking into improving the results, you may want to consider maybe a pre-processing where you attempt to regularize these variance in the sizes of the sun. And I'm not talking about the size of the image itself, but the apparent size of the sun, which can relate to the fact that the images are not the same, but that, no, it's not strictly related to it. What matters is what size of sun your activation layer and your perceptron is actually looking at. That's all.
We have a few questions in the chat as well. I don't know if you want to
Well,
wait until
let
the
me,
end, Troy.
before we get to some of the chat, we're not done yet. So
Yeah.
I should have waited on Raphael's comments because we haven't even talked about the CNN yet. So we just were talking about the bag of words. And so now let's talk about the CNN, so that what Raphael was talking about can be put into the context of this, how the CNN works. So Troy, can you kind of talk us through this diagram?
Yeah. So convolutional networks take as input an image and basically break the image apart and create a convolution which it associates pixels and creates features out of them, and then pulls those features together to associate things together. Like I said, like this shape of the moon and like what a dog looks like as a sort of extrapolated example. and then those are put into a predicted bucket, if you will, of the 0 to 25, et cetera, et cetera. And the convolutional network here, I believe, worked much better than the bag of words specifically for total solar eclipses.
So Troy, can you kind of talk through, I know you did a bunch of this with animals yourself. So like, let's say you had an input of a dog, like you're saying, and then all the pixels of this image of a dog, but let's say it's from one angle or something, gets pulled apart. What do you mean? So each of these boxes then is like some aspects of those pixels?
So
Yeah,
it looks at all of the pixels and makes it tries to find features within them, constants that are like this colored pixel next to this colored pixel, and then that moves to a second layer. But then if these two pixels are next to each other and these two pixels are next to each other, then we're starting to begin to see a curve, and then we can extrapolate that curve to be like the shape of a nose. It's the compounding of many very small features that we can associate together, which is the many layers.
that's this convolution, many layers. And
Yes,
then,
and all of this is an automated process. It's very rarely that you will do them manually, because it's
right.
a lot of pixels and a lot of calculation.
And then so I now like through the convolution, you kind of figure out you've got a nose that looks maybe like what you get fed in as labeled data, that's a nose. And then what happens in the pooling section?
The pooling is where it's going to guess what it is. The pooling is where it decides. Oh, no, that's not right. I forget what the pooling process is.
It's depend. You have max pooling, for example, and so it's a way to bin the data further with a binning rule, and so it again makes a reduction of the size of the feature, but that depends on your pooling rule. So there are different pooling. The typical pooling rule is max pooling, where it's gonna grab the most salient feature by taking the maximum of your sort of activation number. Basically the maximum of what this perceptron is sensitive to. Because by definition, that would be the most salient feature that defines that part of, that characteristic of this image into what it is. So that's what max pooling does, is simply boost the most salient feature.
Okay. So it kind of weights
Yes,
that.
it adds up some weight. Yeah, exactly. Yeah.
Okay. And then now that you've got that weighting, and so then what does the fully connected mean?
Again, I don't remember off the top of my head. It's been a
Uh,
while since I've put together
you
one of
did that.
these.
So it's actually, you can use really your diagram is well drawn for that. So you see, you in input, in convolution, in pooling, you have all these squares.
Yeah.
That means that you're still dealing with sort of images. They're
The
still
images.
images.
Yeah.
Sort of reduced, but they're still images. We call them features. They are 2D, two-dimensional, but they're in a higher dimensional space. So they're not, the value of the intensity is unrelated to the intensity of the original image. But they are still, 2D matrix, so to speak. But then when you arrive in those little circles that you see, then you've achieved the maximum possible sort of reduction in size. And so you're basically dealing only with, I would say, scalars, with numbers. You're not dealing with images anymore. And so this is why it's at that point, you're fully connected to the output, because between that layer of fully connected stuff and the output, you have a standard neural net, very standard. It's not taking images as an input. It's taking those little circles, which are basically just in real numbers. and it's gonna make a little sort of statistics to tell you in the end what is the original image representing in terms of classes. This is a class 1, the class 2, the class 3. So which would be, I don't know, the percent of partial eclipse that between 0 to 25 is the one's going to be. So that's basically your ultimate classification that's being done right at the end. And it's taking as input the last sort of numbers that have been derived from this pooling part, which are just mostly real numbers.
Wow, that's crazy. It can get that abstract. And then it pulls into, now we've got our confusion matrix for, so this was also, just so we are very explicit, this was with the 2017 data. So they weren't binned in any way. I mean, we didn't bin them, and we did not process them. And so even without that, I thought the accuracy was pretty good here, 88%. But you're saying now, Raphael, that if we kept sizes the same, we would get.
I honestly, I do not know how this bag of word work.
Well, no, this is the CNN.
Oh, that's the result of CNN. Okay, yeah.
Yeah.
So if you
The
want
bag
to
of
increase,
words had 70% accuracy.
I see. Okay. And I cannot comment on the bag of words, and I apologize earlier. I think I shot my question too soon. I thought you already talked about convolution.
No, it's all good. It's all good.
Yeah. If you want to increase the accuracy, and honestly, it's already pretty good there. So probably the range of images, of sizes of images were still, I would say, reasonable. But I just realized that there is something pretty easy you could do if you want to pre-process the image without penalty in computing time. Is that hopefully, I remember that you requested the images to be, whatever the camera was giving, so you probably have the metadata in there, right?
Yeah.
Okay.
Well, yeah, we will.
So the size of the sun is directly related to your focal length. And so if you have the same sensor size everywhere, but different focal length, then if you want to regularize the size of the sun, you simply have to do a basic linear regularization of the focal length. So if you have someone gave you a 200 millimeter focal length and someone else a 400 millimeter, well, you know that the one that is 200 millimeter has the size that needs to be multiplied by 2. And so you simply do these linear relationships, and for you can get the sensor size also from the metadata, and you basically have the linear relation for how much you need to expand your image or shrink your image to make them to make sure that the size is actually the same. The sun is actually the same size. And finally, if you have sensors of different sizes, you need also to take that into account. APS-C sensors, there's always a crop factor of, I don't know, some 0.6 or 0.7, I forgot, that you need to account for. But it's basically a multiplier on your focal length if you want to have the full frame equivalent. So it's just about finding that little linear factor. And if you're doing that through TensorFlow or PyTorch, then you simply add the one of these linear image transformation in the pre-processing layer, and that's going to do that automatically for you if you give it the the factor of expanding or shrinking.
Right. Okay, great. So I think we have there's a little more here, results. So here's some correctly classified images. And so you can see the 0 to 25% eclipse. This was one. It correctly got it. Here was a 25 to 56% eclipse. And a total eclipse. Both of these were picked as total eclipses. And then here were some incorrectly classified images. So this was predicted to be a little smaller than it actually was. This was a diamond ring, but it was classified as a partial. And I mean, this one, who can really blame the machine? It's so fuzzy. And then who can blame the machine for this one either? I don't know. I think we would all have trouble too. Like, is this going to be a total or not? But yeah, ground truth, I guess we would say it's not, but it is. So, you know, they're just like humans, we might.
Just on the last one, I'm confused because I'm seeing a total eclipse. So why is a ground truth not an eclipse? Did you mean?
Well, because this was attached to the image. Someone had put this.
Oh, sorry, I didn't realize. Okay, the bubble was.
Right, the bubble. I know. Every time I
Yeah.
look at this poster, I'm like, what's wrong with that? Oh yeah, the bubble was on the image. So someone uploaded in 2017 a total solar eclipse with the bubble.
That one's hard because you could almost make an argument that that is still a total
Yeah,
eclipse.
I think your neural net actually did what he was supposed to in a brilliant way, because he simply say, yeah, I see that thing is weird, but I'm still seeing a total eclipse, just like a
Right.
human would do. And
Which is the power
then
of this, of
that's
the
good.
machine learning, right? Right. Is to say, I'm going to ignore the bubble because I still see a total solar eclipse. So these were the conclusions the students had, is that CNN is a better model to use for classifying these images. Although I think that someone in the comments had noticed that the diamond ring was pretty well classified, but in the bag of words, but then in this in CNN it maybe had found fewer diamond rings. And when the student was explaining the bag of words to me at this poster, he told me that this algorithm looks really for it kind of approaches the images in a small, like looking for smaller features in images, and so it actually makes sense that it would find an image that had more features, and that's what you have with diamond rings, right? You have this kind of extra blob. Where is that? Over here. Sorry if I'm making you all dizzy, but here you have this extra feature in the diamond ring that you don't have in the total eclipse. And so it could be that the algorithm's just able to pick up that extra feature a little better.
Yeah, and it's pretty understandable why it would also be misclassified as a total solar eclipse.
Right.
Someone is asking, what does the bubble say? And actually, I'd like to know too.
I'm
What
actually
does
pretty
the
curious
bubble
as well.
say? It says SAS photo memories. Okay, so I think we have a bunch of questions. I'm going to stop sharing so that we can get to the questions. And we clearly have some people who have done machine learning before. So we might have to, some of these questions we might have to actually email Abina and have him share out the answers. But let's see. I have Kaz and Heather say, I have a couple of questions. How to deal with the imbalanced data set. So I think Troy mentioned a little bit about that, which was the synthetic, basically creating a synthetic partials in order to balance partials with the total. And then the other way of doing that was to label more data and label more of the partials. But I guess the whole data set's also
The whole data set, the data set as a whole is truly imbalanced.
Right. So Troy, maybe you can say more about that. Do you have more things to say about that?
Well, truly beyond doing the synthetic data, there isn't much to do about it. It's just one of those things where we just took more total solar eclipse images. And we could, in theory, maybe get external images that are not from this project to supplement it. But there's just not much to do about it.
Yeah, I like that idea. The next question from Kaz and Heather, is the CNN model for multi-class classifier or the layers or two-class classifier?
I believe the answer is multi-class classifier because it goes into the many different classes, but I could be wrong.
Okay, so we can double check with Abina. What is the manual classification? Human experts check one by one?
Correct.
Yes. Okay. Wick asks, is there a way that the lights and darks are linked to the images that are sorted? Does the corrections based on light and darks done later in the process? Okay, so I'm gonna come back to that question. We didn't for this particular machine learning project, we didn't deal with lights and darks except to classify them, and they were not linked to the images. But I'll talk about that some more. Do you have anything else to add about that, Troy, in terms of the machine learning projects?
No, I don't believe they did anything special with lights and darks.
Yeah, I don't think so either. And they were not connected. We didn't say, you know, these are the lights and darks from this particular user in this particular in this. We didn't tell the students how they were connected. So from their perspective, there were no connections. And yes, Steven says confusion matrix, anything off diagonal is a mistake. So I think we got through that. Praveen says bag of word method should be more effective in NLPs. What's an NLP?
Natural language processing.
Okay, do you want to talk a little more about that statement?
Sorry, that was Raphael. But yeah, you should let me clarify.
Yeah, or Praveen? Okay, you don't have to. But we would love to hear your expertise if you would like to share. Do you have prediction, recall, and F1 scores in addition to the accuracy? Troy?
Not as far as I'm aware. I don't think they did F1 scores.
If you ever publish that in a paper, I would recommend them to output that information. It's not, I mean, the framework can do that for them. They don't have to calculate that manually.
Yeah. I just don't think that when they put it together, they were calculating the F1 scores.
Okay, good to know. Just for the people in the room who don't know what an F1 score is, can someone give us a summary statement?
I can. Don't want to steal the thunder of anyone. Troy, go for it first.
It is, if I'm remembering correctly, is a it's similar to the prediction score, but it's over many models worth of testing.
What do you mean? Many models worth of testing?
Like when you would do the prediction model and get a random set of images through one sort of prediction test and you get the accuracy score. This is over many iterations of it, and it gets
Yeah.
you I guess an average over many models.
That is correct. But on top of that, the F1 score has the characteristics to deal with the problem of unbalanced classes, which is exactly what you described at the very beginning is a fundamental problem because you may have much more images, samples of total eclipses than you have of non-total eclipses. And so you have, by essence, an unbalanced training set. The F1 score tries to mitigate that by making it as if you had a balanced, evenly distributed sample set. So it's a more accurate metrics than other metrics. F1 score. This is usually why it's recommended to, when you publish a paper, to put your F1 score.
Right, makes sense. Okay, Wick says, are the data inputs in camera raw format or have they been converted to a common format? Great question.
Both, if I'm remembering correctly. I think some of them are in raw and then some of them are like JPEGs.
And yeah,
I believe they had issue with some of the raw formats. When we had spoken to them on a couple occasions, they were having trouble um, getting some of the raw formats to load. I don't know what they ended up doing with them, but I
Yeah, I
just
think
remember
they
them
just
having
didn't,
issue with it.
they didn't go through all the rest of the data, I think.
You always
But they
think
did
that
have,
next
but they,
time- Oh. I
yeah,
was
what?
saying, consider next time that everybody converts them to DNG with an Adobe converter or something, so that you got all the same formats to work with. Just a thought.
Yeah, I think they were wanting that for sure. A lot of this takes, yes, time.
Laura, when you say they, actually, so can you remind me what who you're talking about? Who is actually doing all these processing work? Is that students at the university?
Yeah, we
or-
had
There's students, yeah.
three undergraduate students, computer science students here at Sonoma State University. So this was their capstone final class
Okay.
for their degree. So they're out trying to find jobs now. Yeah, and this was, this was an added bonus. This wasn't part of the original, proposed effort. But our professor here at Sonoma State said, "Oh, I think maybe we could come up with a student project with machine learning," because he teaches machine learning. He as one of his classes he teaches, and he has a PhD in image
It's image processing.
image processing and machine learning and such. So he was very interested in finding out, like, what could the students learn while they're doing this, and how could that help the project. And so this was what we were able to come up with as a task for them. And that will be, I mean, the code will be used, in fact, as we go forward. But so that's kind of the context for their work. Do you consider, okay, Cousin Heather says, they say, do you consider to use image semantic segmentation model to detect the objects, like the shape of the sun, as a feature after fine tuning the model, like semantic anything model? Did I even read that correctly?
I'll be honest with you, don't know what either of those are.
I don't either. Maybe
But I'm not also understanding quite the question, because maybe they could clarify, Kaz and Heather. To me, semantic anything model is a promptable model. So you need a human intervention to, for example, select a square around the sun to sort of focus in and tell the algorithm where it should look at.
Yeah, so
That
semantic anything model, I think Facebook developed and released for the public now. That is giving the image and then masking any object in it. And then they can fine tune it as well. So if we specifically, we have the already level data and then giving, oh, this is the one object in it, so that the model fine tune it to detect it, so that the new unknown image given then say, oh, this is the 50% shape of the sun, or this is the total eclipse picture or something, so that the directly giving some model. That's kind of like another neural network models, but different approach than the CNN.
because the CNN, by essence, is a semantic segmentation model. What they're using, this is semantic segmentation, because you have both a classification and a segmentation altogether. So by definition, they are doing semantic segmentation. What I was not understanding was what you meant by fine tuning with a semantic anything model, because yeah, Facebook developed it, but that's meant to be something where,
Yeah,
for
there is
example,
dog shape or car there or tire there or building there, windows there. So like we added some additional feature that
oh, I see.
you know
Yeah,
is
I
that
see.
like
Okay.
20% of the sun covered by moon, or this is a total eclipse, or this is the like just black background image, or that kind of like additional new levels that original vanilla model doesn't have. so that our own customized model can be, added in the additional feature to improve the performance. That's what I pop up the idea.
Okay, I understand. Okay.
Maybe we
Then I
can.
guess the answer is no, that they didn't use.
We have not considered this, clearly. But I think so we're going to be, one thing I typed in the chat is Troy, Hannah and I are working on a CAGO competition to kind of further these efforts. And so maybe some of you or others might use that approach. And we'll see how you do. Great. Okay. How would you like to talk about your data and processing retention strategy? The equivalent of a lab notebook, but for computational modeling, says he. The equivalent of a lab notebook for computational modeling. Are you talking about the open source aspect of this, he?
I'm talking about the long-term reproducibility, like 10 years from now, 15 years from now, if you want to go back to this, how much reinventing of the wheel do you need to do?
Right.
Right, because if I open a paper, it gives me the results, but it doesn't give me the fine detail of how the scientist or engineer, the blind alleys that they went down, and all of the other stuff. And so from my perspective, that's an equally important part of research, is to document what didn't work. You may not be able to publish it. They don't incentivize you to publish. Well, I dropped the thing on my foot, and so it's not working, right? But it is important to retain that institutionally in some aspects.
Mm-hmm. Yeah, no, that's a really good point. I once, when I was in grad school, many, many, many years ago, we talked actually about starting a journal that would focus on that. Like, you would be required to have that after your introduction, because we felt like it was missing so much in terms of knowledge gained and sharing that information. But of course, that never happened. So, but it still, I think, should happen on some journal somewhere. Like, that should be the story of your journey of, what worked and what didn't work, and like why not to go in certain directions that people might think is obvious. I think maybe we could do like a blog or something, where it's captured on our website, and then that's something, websites have pretty longevity. We can wrap it all up.
Well, yeah, I'd encourage you to think about that. Like, I'm trying to influence the scientists and engineers at my institution to do that internally. So I'm just posing that question whenever I have the chance externally.
I love it. I love it so much. So let's I will, I think Hannah, Troy, Juan, and I would we definitely value that. I agree.
Yes, Jeffrey, I totally resonate with that. Let me
Jeffrey
see if
writes
I can find a
failure.
good emoji to
I know, you'll have to find one. Failure and the means of its avoidance tend to get passed on within research groups, almost like trade secrets. That's right. That's a fact. And if you're, say, a Hispanic serving institution that doesn't have a big research initiative that happens over years and years and years, I can tell you, having come from Berkeley, where that ethos exists and all those little tips and tricks exist and are shared, and now working here in an area that I'm not super familiar with in terms of a CubeSat and the engineering, there's no institutional knowledge about which tricks not to go down and which paths not to go down. And it's really, really hard. So I really love this idea from an equity perspective and from a perspective of kind of sharing those trade secrets as much as I can from this project. I mean, this little project about the sun. I think that's great. So I'm all about, I think that's great. Thank you, He. Yeah, no one wants to help the competition. That's true. And you don't need to but that's why some of us get funded too. We're trying to help your competition. Sorry. But I know it's a real concern from institutional perspective. I agree. Which camera raw data didn't load? That's a good question. We'll have to get back to you on that one. I don't remember. Troy, do you remember? You don't remember probably either.
I don't remember off the top of my head.
I kind of think it's Nikon. But
Some of the newer Nikon formats, I don't, and Sony formats, I don't think have been published totally yet.
yeah,
And so they want you to use their software to turn it into a TIFF or other defined source.
You
right.
mean
Speaking of trade
the
secrets,
raw format, the raw format hasn't been published?
I think that's the case. I know that the newest Sony's are not quite, they keep on saying real soon now, but yeah, famous last words.
That's right. You can I left you a note, P, on your question about conversion of raw formats. But there is an excellent library that I recommend, and I think the students must have used that because there are not many out there. So what you say is true, but there are very smart people that have reverse engineered the raw formats of all the common brands.
The major guy. Okay.
Yeah, and like I'm checking now, like even the A7R4A, which was not the most recent from Sony, it's already supported. So I mean they're pretty on top of things, and it's pretty good because they make it open source. So I'm sure it's not something the manufacturers are too happy about, but yeah, it's out there. And I put the link to that, and yeah, maybe the students actually know about it and use that.
I don't think they did, Raphael, because they were still asking us when they graduated. So we didn't know about that particular. We should have asked you. Next time we'll ask you. We did have a different Python library that did like they couldn't open TIFFs, and we're like, what? That's not right. You should be able to open TIFFs. So we found the right.
They may not be aware that they were using it because the Python things, they actually usually have these dependencies, and very often down the line they use libraw. They use that library. It's not just immediately apparent to you because it's a dependency and it's kind of transparent to the programmer. So maybe the student in the end found that Python library, but under the hood it was actually that.
Great. And then Wick, I see you put use this to put everything in the same format instead of having different raw image formats. Wow, what a this is what Hannah was saying, that you all are definitely part of this team, and I hope you feel like you are, because you are. So
it's a free download. It doesn't cost anything. It does 600 cameras.
600 cameras, and it doesn't cost. That's amazing. That's fabulous. And speaking of, we're compiling the database of people who said, yes, they would like to get something from us. And because we did 2 surveys for that. And then we're getting all your addresses. A lot of you gave us your addresses, and we have things to ship out. And anyways, we are working on that. We just keep getting derailed by other projects that have deadlines as well. So I really apologize for the timing on all of that. But I just want you to know we really are appreciative of all you've done and all you continue to do. And you will be duly, you will hear about that in a mail, a mailing in a bit. Okay, what else? As a postdoc, my first question was always, did you actually check that it's plugged in? Sensor which has no noise has not been plugged in. Indeed. Okay, all right, well, I think Dar just said we're way over. Ha, whoops, I didn't even notice, and I'm supposed to be somewhere at 6:30, and it's about 15 minutes away, so we'd better go. All right, better go. Thank you all, thank you so much.
Thanks, everybody.
We'll talk again in a month.
See you next month. Thanks for coming and for all your fantastic questions.
Bye, everyone.